Perfect. Hi, everybody. I have the great pleasure of introducing Justin Richer, who, if you pick an OAuth-related spec, I'm pretty sure that Justin has had his fingers in it. So he is a co-editor for the NIST 800-63 spec. It's a very good thing to ask him about.
But not now.
Not now. Token introspection, which I was just mentioning. Him. Dynamic client registration. So you're talking to somebody with a deep knowledge of the specifications and a ton of experience in what works and what doesn't. And I'll leave you there.
Thank you, Pam. All right, good afternoon, everybody. My name is Justin Richer, and I'm an independent consultant based out of Boston, and I'm here today to talk about transactional authorization because last year I talked about everything that is wrong with the OAuth 2 protocol. And that talk went really well, and it led to the community giving some really great advice to people, especially around using the implicit flow. Because as it turns out, developers, when you tell them that something is an option, they're just going to use it because it makes sense to them. They think that it's simple. But developers also, it turns out, really don't like being told what not to do. There's a lot of issues that come up around that. But that's not really what I'm here to talk about today. I already gave my rant about the implicit flow this morning. I'm here to talk about the idea I had over the last year about there being an underlying singularity to a lot of the extensions to the OAuth protocol that we've been seeing come up in the last few years. And in my talk last year, I said that there was probably this singularity there, and a lot of people asked me to make a prediction of what that is going to be and what that's going to look like. And I had to tell people that I really don't know. And well, I don't know exactly what it's going to be, but over the last year, I've had a chance to bring together a lot of really smart and talented people that have some really important use cases that they're trying to solve, which OAuth is kind of hitting at the edges of its capabilities. And in this last year, I've been slowly reaching the conclusion that I think that the future of these kinds of use cases is, in fact, not OAuth. Now, this might seem a little out of character for me, because as Pam mentioned, I do a lot of my work with OAuth, and I've got a little bit invested in the continuation of the OAuth world. And I will say, just as I did last year, it's not going anywhere. OAuth is really, really going to be sticking around for a long time because it does its job and it does its job well. But you got to admit that once you start adding everything together on OAuth, things are starting to look a little bit weird. So let's go back to the chalkboard a little bit, all right? Time to go back to school, because if you are able to believe or even concede that indeed the eventual effort of twisting this technology is enough to make your brain ache, well, then I would propose that we have become jaded against change, even when that change might be okay. Because elements that we already know have a way of appealing to us. I'm not sure why. Maybe it's because we think they're cute. But these are some really troubling habits, especially in the light of security violations and breaches and abuses, which seem increasingly severe and worrying. Because when every day it seems that the problems double, you don't really expect the eventual solution to wind up looking easier than what it's replacing. Thank you. So it's with that I want to introduce a project that I've been working on, which is currently called the XYZ project, because one, I'm terrible at naming things, and two, on a bit of a lark, I bought the domain oauth.xyz a year ago, so I had a place to put this, and that is live now. You can go check that out. We're going to see things that are a little bit similar to what you may be used to. We're going to have a client, an authorization server, and a user, and they're going to talk to each other in similar ways, but I want to remind everybody that this is not OAuth. This is not a profile of OAuth. This is not an extension of OAuth. What I wanted to do was to be able to take a step back and see how we could do things a little bit differently, because it turns out that a lot of problems in OAuth come from its use of the front channel. Now, as a little bit of a reminder, the front channel is also one of OAuth's greatest strengths because the user is present, the browser is very versatile in how it can interact, you can do things over time, and you can ask for multiple types of credentials and stuff like that. Really, really wonderful. The problem is that from a security perspective, it's really awful because these redirects leak stuff all over the place. They can be tampered and injected. Now, this is all well and good in the world of sort of core OAuth. The problem is that OAuth today, especially, uses the front channel for everything. It's all over the place. So when you take those aspects together, this becomes what we would call a really big problem. And so much so that we are trying to protect the front channel with all sorts of additional add-ons. OpenID Connect invented a whole bunch of ways to do this, jar, jarm, pixie, token binding, may it rest in peace. And my proposal, taking a look at this, is, well, what if we just stop using the front channel for everything? Let's stop making a problem so that we then have to solve it. In order to do that, we had to take a little bit of a step back, and I decided to see what it would look like if we made transactions be a core component of an authorization protocol. Well, because OAuth has always been kind of transactional. You take it from one step to the next to get the token and get it authorized, then you get the thing. But I wanted to make that explicit instead of the implied transactions that OAuth 2 has. So we're going to start by registering intent. We've seen this kind of pattern before. And in this protocol, in the XYZ protocol, this starts with the client talking directly to the authorization server and saying a bunch of stuff about itself and what it wants. So it's going to send a JSON document, it's going to post it over, and it's going to say, OK, so here's some stuff about me, how to display, my homepage, all of that kind of stuff. But I'm also going to be able to tell you what I want. Now, in OAuth, we've got a list of scopes, simple strings. In this, since we're posting a JSON document that doesn't have to live on URLs, we've got the ability to do much more rich and varied structures in here. And there's some really interesting work that's coming out of the ITF right now to work on that. And I also might, as a client, know something about the user that I can tell you. Maybe I can send you an assertion that you can validate. Maybe I can send you some verifiable claims that you can process in the backend. But if I know something about the user already, maybe you don't need to go bug them. And finally, I need to be able to tell you how you can recognize me. In OAuth, this started as the client secret and got tied to a whole bunch of other things. What we have here in this protocol is the ability to say, this is how you'll recognize me. I'm going to present this key. This is tied to a key presentation mechanism that the client has to prove possession of any referenced keys when it makes this call. So the authorization server can say, like, look, you really need to, I really know that it's you because you said you have this key, and I can prove you have this key, and I know that this key maps to a certain set of rights. And the last bit of information is, how can I interact with the user? Because in OAuth 2, a lot of the differences for the different grant types boils down to how the client can represent itself and how it interacts with the user. So instead of baking all of those into this one thing called a client and trying to make it be all of these different aspects, we decided to, let's split them apart. So the authorization server is going to take all of those things, and it might decide that, oh, hey, I have everything that I need in order to grant an access token. Maybe it's just for this particular client. Maybe you gave me a bunch of verifiable claims. I can do this. That's great. But a lot of times it's going to say, you know what, I need to talk to the user. So the authorization server is going to then create what's called an interaction URL and hand it back. This is a lot like OAuth's authorization endpoint, except that this is a URL that is generated specifically for this particular transaction. It is only used once and never used for a different transaction. And there's also what's called a transaction handle. More on that in just a little bit. But the important part here is that every step here leads to the next. You notice I didn't start with a discovery document because the client really only has to start this whole thing talking to one URL. It goes and kicks off the transaction, and then it gets told where it needs to go to next. And the client, well, we are back in the front channel, except that, notice, there are no query parameters. The client didn't add anything. There's no client ID. There's no scopes. There's nothing to protect there anymore, because the server can then look up everything that it needs to based on that interaction URL. And we have effectively solved the problem of protecting everything that's going through the front channel by just not putting it through the front channel in the first place, right? Now, the interaction happens pretty much how you would expect, and then you get sent back in the front channel. At this point, we hand the client back a state parameter. Where did that come from? Well, the client sent that as part of its initial transaction request in the back channel. The client no longer has to send that through the front, and then we would have to protect it with a hash on the way back or something like that. And we also get this interaction handle, which allows us to connect to the next step. Because once the client validates its own state, so it knows that this incoming call references a transaction that it is currently processing, it then sends the transaction handle that it got when it got back that URL, and the interaction handle, which it got from the front channel. It sends those back to the to the transaction endpoint, and the authorization server can then process it. But note that the client still has to prove possession of all referenced keys in this transaction every single time it talks to the authorization endpoint. To the transaction endpoint. I'm getting my OAuth terms mixed in here too much. And at the end of all this, the server can say, hey, here's an access token. You have satisfied everything. You've got a user to interact. They said, yes, everything's good. We can go on. Right? And all of this ties together with these things called handles, because a handle allows us to reference a previous bit of state in that transaction, because we are now admitting that the transaction is its own entity. We can do something with this. This goes beyond just the transaction itself, because the handles can reference parts of the transaction. Now, you probably don't want the client to have to send its entire public key every single time it talks to an auth server, or send all of its display information. That feels kind of ridiculous. In OAuth 2, we get around that by having the clients register, and then the client ID stands in for all of that. Well, with this project, we can have a client handle and a key handle stand in for those previous sections. So the first time the client talks to the server, it sends its whole information, and then all future times, it sends the handle instead. And the server can then go and look it up, and the client still has to prove possession of all of the referenced keys, even if the key is passed by handle. Now, what about refreshing access tokens? I did not have a refresh token in that return. Well, it turns out that a refresh token is really little more than a request to continue an ongoing transaction. Think about it. You have already approved it. You already know who the client is. You already know what they're asking for. You're just saying, I want to keep this thing going. Well, we have a transaction handle that we used in the interaction side. Let's keep using that. So to refresh a token, we literally just say, hey, this transaction, it's still me. I want to do more of that. And the auth server can then decide, oh, OK, maybe it's been long enough that I need the user involved. Or maybe it's fine, and I can just give you a new access token. The client's response is the same in both cases. It knows what to do. Now, maybe once we have the user jump through all of those loops, we want to be able to remember that particular user. So UMA has the persisted claims token, which allows us to remember that at the client side. We can do that with a user handle here. So this handles concept really kind of carries down through all of this. And let's get back to OAuth scopes. One of the best things about scopes in OAuth 2 is that they tend to be short and simple, human-facing, human memorable. Well, what is a scope except a string that represents a set of access rights that are being requested? In other words, it's a handle, but for the resource section. And an important thing here, in addition to having some nice predefined scopes, I can also have a structured scope right alongside of them. All right? So how do we deal with other devices? OAuth 2 was written in a world where it was all web servers talking to other web servers. And it turns out that in a lot of cases, you really get down to it, the difference is in how you interact with the user. So we have that section that says, I can interact with the user. And previously, our client had said, oh, hey, I have this callback URL that I need you to send them to, and there's the state parameter that I'm going to be looking for that. Well, now we're just going to say, I'm a dumb device. I can't redirect the user, but I could tell them to go somewhere and enter in a code, and I can't get a redirect back. I can't get a callback. So we simply send a static interaction URL, and then give them a user code, which they can then tell the user, oh, hey, go here. This is the OAuth 2 device flow, but without adding another device endpoint and another extra bit of complexity on top of it, because all of the concepts are kind of built in. Interaction happens again pretty much how you'd expect. The user enters the user code, but notice we have a static URL because we don't have a good way to do like a big, long dynamic URL like we did with the normal redirect-based interaction. Well, we just look up the transaction based on the user code, and we have all of the information that we had before, and we can close that front channel loop without sending extra information through the front channel. Meanwhile, the device is going to go sit in the background, and it's going to pull the auth server and say, like, hey, are we there yet? And it's going to do that by using that transaction handle, and it is effectively saying, I want to continue this transaction. This transaction is in an ongoing state. It has not been authorized yet. And the server is going to come back and say, like, no, not yet. We're not ready yet, but ask me again in 30 seconds, and when you do, use this new transaction handle. Because I now have an opportunity, and I would argue a duty to rotate that transaction handle every single time it gets used, because they should be very short-lived. So I had a client ask me, what do we do if I wanted to combine the URL and put up a QR code? This is something that we added after lots of argument in the OAuth device flow specification. Well, it turns out that at that point, you're just sending somebody to a large arbitrary URL. We've already got a mechanism for that. We just tell you this is the URL, and if you say that you can display a large arbitrary URL as a QR code or whatever, we don't care how you get it to the user or how you get the user there. You can redirect them, you can put it on the screen, you can read out the individual letters. I don't care, just make it happen. We've already got the mechanism to do that. So we've already collapsed a whole bunch of OAuth extensions and functionality just by using the same simple mechanisms. So what do we do with identity? Well, in that response with the access token, just like in OpenID Connect, we can pass identity assertions back alongside the access token. Right? We can do ID token style assertions. We could do verifiable claims, JSON objects. And this is a rich JSON structure that only has to live in the back channel. This is not showing up at the end of a URL, so we don't have to worry about that kind of encoding, that type of armoring. And we can also, like we saw before, push user information on the front end as well, not the front channel, in the front part of the protocol, sorry. And also, we can still have the equivalent of a user info endpoint where you are asking for a certain set of access rights to an identity API, and those get handed back. So what about binding tokens to keys? This has been a big topic especially over the last year. We've got Depop and MTLS and all this other stuff. And well, we've already got a mechanism for the client to say, hey, I can prove possession of this key. Now, the example that I gave was something that was JWK-based with a JWS detached signature over the HTTP message. That could just as easily be a certificate thumbprint and using the TLS channel. All of those mechanisms can be defined as ways that the client can prove possession of a particular key. So what if we just said, all right, so here's your access token. And instead of telling you that this is just a bearer, you can use this access token only if you can prove possession of the following key. This may be a key that you registered, or it may be a key that we gave you. The key proof is passed alongside of the access token. And again, this is the detached JWS flavor of this. There's a lot of different ways I could see this playing out. So all of that in mind, this project is still very much in the early stages, and I would like to see people get involved. Right? I've really only been working on this in earnest the last few months. We are very much in the take chances, make mistakes, and get messy phase of the world. And the part that worries me as an engineer is that so far it works really well. And I don't trust it. So I need people to poke at this. I need people to help me find the edges of this because I haven't been able to yet, and that terrifies me. I know that they're there. So I invite everybody to check out OAuth.xyz. This is where the project is being written up. I will be presenting this at the IETF meeting in Montreal at the end of July with the OAuth working group. So we'll see if it gets taken up there. And once again, I think that OAuth 2 and whatever comes out of this will rule peacefully, side by side. And there will never be any contention between them, because that always works really well. Thank you very much. I will take questions. However, I do want to say real quick, please come to the closing party on Thursday. I will be performing along with Pam and a bunch of other very talented folks in the industry as part of ZZAuth and the Love Tokens as the musical guest. I didn't pick the name. As the musical guest at the closing party. So it's going to be a great time. Thank you all very much. Yes.
I'm coming. Wait.
OK. Oh, Pam's running mics.
So I guess two questions. So
sure.
So this new framework, I'll call it, would it eliminate the authorization endpoint and the token endpoint and the introspection endpoint and keep the user info one, or? OK. So basically, yes and no. So the transaction endpoint that I'm calling it is equivalent to the token endpoint because it's where you go in the back channel to talk to the auth server. The authorization endpoint is what gets wrapped up in this interaction endpoint, which covers the OAuth 2 authorization endpoint, the UMA interactive claims gathering endpoint, and the device flows, whatever it's called there, that thing where you type in the user code. So all of those get kind of wrapped up into this. The important thing is that from the client's perspective, it gets told where it has to go next.
So instead of having to go grab this discovery document, you have to then go and just talk to the transaction endpoint, and it kicks you off. As far as introspection, that's a really interesting question and something that haven't really run down as far as I would like to yet. One of the things that we started to look at was how do we do the wide ecosystem cross-domain stuff that UMA enables. And a lot of it comes down to the resource server being able to sort of bootstrap a transaction by talking to the auth server and saying like, hey, somebody's trying to get this kind of stuff. I don't want a token. I want to signal that I don't actually want a token, but give me some way to start the transaction that I can go hand to somebody else, which means I can then hand somebody a transaction handle that that client can then use to go talk to the auth server and start everything off.
Cool. And then second question is, I know you have OAuth.xyz. Do you have like a test IDP that you can use that has those endpoints built in, or did you build your own, or? That's
a great question. So I don't have anything deployed. What's at OAuth.xyz is just a static write-up site. I do have a Java implementation of most of this that I've been poking around the last few months. A lot of what's there was my attempt to basically say, like, OK, if I make the JSON look like this, how mad does it make Java's parsers? All right, because I figured if I can get a dynamic multimodal JSON-based protocol to play nicely with Java, then other languages, there's hope, right? And so far, it does. So there is a Java implementation of client and auth server. It's not all of the pieces, but it's some, and I would like to see more. Oh, we got like 3 minutes.
We have 3 whole minutes. Oh man, wait. This is like, okay, we're going overland. Pass it over.
All right. Wonderful, thank you.
So just a quick question. With a lot of these generated URLs, so you've got these randomized strings, is your expectation that those strings could be large enough to encode everything that the server would need to do to interpret it through encryption? Or are all of these requiring lookups so that a deployment at scale would have database size or latency type problems with dealing with these transactions?
That's a really great question. So my view on it is that you would not want to make the URLs themselves stateful, because then you run into all of the same problems that the OAuth front channel has today. However, I also want to point out that running something like this at scale, that's one endpoint that has to run at that kind of scale with that kind of lookup. That's not where the scale problems happen in OAuth systems. The scale problems happen at the API and token lookup things, the stuff that Pam was talking about earlier. And they happen on the client side, so clients being able to actually kick things off and start things. If a client talks into a system and then gets routed to the same instance of an auth server, which has a fast lookup to all of this stuff, that's a very solvable problem. And also these types of interactive, the interactive authorization bits from the user aren't going to happen that often in the real world. Like, it's not going to happen nearly as often as generating new tokens and refreshing them and all of this other stuff. Like, getting a user involved is kind of a big deal. And if we can make that decision without getting the user involved, which a lot of especially enterprise and large-scale applications are saying that they should be able to do that. That's why we have token exchange and all of this other stuff that's going on in the OAuth world. Then we don't even have to hit those. So we solve that problem not by patching it in, but by avoiding it.
Here.
Right here.
Hi. Oh, thanks. And so how do your JavaScript SPA apps fit into this?
Great question. A couple of different things. One, so I covered this in my OAuth class this morning. A lot of times it turns out that doing the actual security processing inside the JavaScript is not really the best idea. A lot of JavaScript-based SPAs tend to have a split architecture where you've got a back-end system and a front-end system. Do your tokens in the back end and use session cookies to talk to the front end. That said, where you're talking to the front end, where you actually have the security things in the front end, then this still works. You put cores on the transaction endpoint, and everything else just kind of falls through.
With the key material? for the client?
Yeah, so the key material for the client can either be generated at the time that the client is downloaded to the browser, or it can be generated at runtime if you really want to get crazy with the Web Crypto API.
Yep. Okay.
Please solve that, FIDO people.
All right. We got one more. Do we have time?
I think one quick question.
As long as we're not egregious.
Oh, just yell at Annabelle.
Here, wait, I'm coming.
Oh, okay. Sorry.
Here we go.
So you mentioned the state parameter.
Yes.
And that would be initially sent over in the initial request to start the interaction. That implies that the client has to have that state parameter ready when it makes that initial request, when it does not yet know whether or not it actually needs to do this trip through the front channel.
Yep.
So that means potentially you're requiring a client to upfront push a bunch of data into a database, get a handle for it, and to send it over in this interaction request when that may not actually be necessary. So you see that as a potential problem in terms of putting in a bunch of load that's may not be necessary if, as you say, we get to a world where we don't actually need to make that front channel request very often?
I don't think it ends up actually being that much of a problem. I'd love to have the conversations about where this could be, because in my view, all that the client is doing is saying that if I need to interact with a user, I am prepared for that. So if it's that big of a deal for the client to do that, then it can make a request without an interaction section and say, I can't interact with any clients right now, but do I get a token anyway? And yes, you pay a round trip, but you don't pay the cost of doing this. I think in the end, people will be more willing to pay the setup of having this state value come back that they can then look up. But having the flexibility for that decision, I think, is important. Yes.
Yeah, I was just going to say, I think the flexibility, having room for a few different models there would make sense depending on the nature of the client, the kind of data they're dealing with, and what's the relative cost of serializing that or getting a handle for it.
Right, exactly. Thank you. And of course, we don't want to encourage people to pack state into state and things like that. I've got some ideas about how we can use hashing of these various parameters in order to enforce that, but a lot of that's written up, and I would love to continue this conversation. Thank you all very much.